show the benchmark test of complex matrix multiplication. And after that, we explain optimization of complex decomposition with complex matrix multiplication. And then we show the benchmark test of complex decomposition. And finally, we conclude our talk and we show future work. That is the motivation and goal of our study. Now we have MP Park and MP Plus library provided by Nakata to solve ill-conditioned problems that require long precision floating point operation. But,
Excuse me,
uh,
Koya-san.
okay.
So now the slide is on the title. Yes. Could you switch to the full screen mode? Was the slideshow?
Oh, okay. Uh, now we show the third page, but now now other participants can only title page.
I
You can see
can look at the third page.
Okay. Now
Just a moment.
okay. Can continue to
Excuse
talk.
me. Somebody want to speak.
I'm Fukuko Yuasa. Slide does not work. The same page is shown.
Okay. So okay. Sure.
Currently, page 3 is shown.
Yes.
Okay.
Now
Now you stop the presentation.
no we so we
Now sharing the screen is off. Maybe.
now okay.
Okay.
Yes. Now I can see your screen, the third page. How about otherwise?
By switching full screen mode, the participants can only title page. Right. Okay. So
Nice. Okay. Please continue with this mode.
Okay. This by using this mode, I continue to talk. Sorry. So we are focusing on developing faster matrix multiplication linear computation library optimized for multi-core CPUs. Now we have developed a BNC multi library version 0.21 has been released on GitHub URL. Now we are developing a solver for ill-conditioned nonlinear equations using mixed precision computation. That is very important to be accelerated by using efficient complex linear computation. So we are we are developing complex linear computation functions. That is the formats of floating point numbers we are targeting. Of course, including we are of course standard floating point numbers with hardware support are very important, especially IEEE binary 64 double precision arithmetic are very important to get a better performance of multiple precision floating point numbers. Such as double precision, triple double precision, and quadruple double precision, multiple precision arithmetic. We are concentrating to accelerate these three type of multiple precision floating point arithmetic. That is a list of categorized functions in BNC multimil library. Now we have developed BNC Matmil version 0.21 that have implemented real matrix multiplication and its optimized version with simultaneization and parallelization. And now we, as described previously, we are developing BNC Matmil next version, including complex linear computation. And today's topic is complex LU decomposition in developing BNC Matmil version. And in our BNC Matmil library, two matrix multiplication algorithms. One is Strassen algorithm, and another is Ozaki scheme. We cannot show the Strassen matrix algorithm by hiding the figure, but the Strassen matrix multiplication is a standard one. It's standard one of divide and conquer algorithms that can reduce the number of arithmetic. But Ozaki scheme is also reduce the number of arithmetic by using division of long precision matrix elements A and B like this. So when we multiply of A and B to produce a C, matrix C, we can use short and efficient matrix multiplication functions such as dgem provided by optimized current numerical libraries such as Intel Math Kernel and OpenBLAS libraries. And when we implementing complex matrix multiplication and LU decomposition, we want to use faster algorithms, 3M methods. 4M method is standard complex multiplication algorithms that include 4 real multiplications and 2 real additions. But 3M method is 3 real multiplications, but 5 real additions. So when we normal complex multiplication, 3M method is not efficient. But sorry. For multiplication of complex matrices, 4M method, 3M methods can be more efficient than 4M standard 4M methods. One of good example. Breeze library is one of good example to provide to choose 3M complex matrix multiplication based on dgem functions. And we employ a data structure of complex vector and matrices shown in right figures like this. So by division, storing by division to real part and imaginary part in complex vector and matrices, we can use simultaneous load and store functions to accelerate the complex linear computation. So we show the result obtained by using benchmark test of complex matrix multiplication. Complex on AMD EPIC computational environment. That is the result of benchmark test by using double-double, triple, double-double, and quadruple double precision complex matrix multiplication. According to the result of our benchmark test for 3M methods and its simulation can accelerate complex matrix multiplication, and in double-double precision and quadruple-double precision complex matrix multiplication. Ozaki scheme and block 3M matrix multiplication are efficient, more efficient than another algorithms. So we can get better performance by using these figures, by using these algorithms. But in triple-double precision arithmetic, simulation slow down the performance of triple-double complex matrix multiplication. So in triple-double precision arithmetic, simulation is we avoid to use AVX2 simulation in complex matrix multiplication. So we explain the optimization of complex LED composition. Now efficient LED composition use the efficient matrix multiplication when updating this square part. L21 and U12 multiplication can be implemented by using efficient matrix multiplication. So we can optimize the change. We can optimize by changing the width of this the width k to find the best point of LU decomposition performance. Now, we have experience to implement and get better performance by using simulated normal LU decomposition. Normal means no use matrix multiplication. So in implementing when we implementing complex LU decomposition, simulated normal LU decomposition is it's very important for users to get a best performance. So we prepared simultaneous complex operations such as BNC FX2 function, addition, subtraction, multiplication, division, and reciprocal functions. And of course, we parallelize complex LU decomposition by using OpenMP functions. That is this figure shows the way to use simultaneous load and store functions to accelerate complex operations like this. So we can by dividing the parts of real and imaginary part in complex matrices. We can use store and we can use load and store functions in matrix multiplication. Now we show the comparison of parallelization performance of normal LU decomposition. Normal, as we have explained previously, normal means normal means no use of matrix multiplication. So in double precision, triple precision, and quadruple precision, simulation show a better performance, especially in double and quadruple precision. Reduced parallelization, we can reduce parallelization efficiency by using civilization. A little bit reduce parallelization efficiency. Especially in triple double precision, some different change of performance can be shown like this, but overall computation time reduced by parallelization in three types of floating point arithmetic. And now we show the result of optimization complex LU decomposition with complex matrix multiplication. At first, we show the comparison of relative errors of three precision LU decomposition. In double precision, Ozaki scheme need a minimum relative error with 6 or more divisions. For triple double precision, Ozaki scheme need 3 or more divisions. In quadruple double precision, Ozaki scheme need 12 or more divisions to achieve the best approximation by using complex LU decomposition. But MPLA pack is also can get the best the smallest relative error for double and quadruple precision normal LU decomposition. So, but another our implemented LU decomposition we can enough satisfied precision by using Ozaki scheme. Now we show the result obtained by using benchmark test to compare computational time of complex LU decomposition with complex matrix multiplication. In double precision arithmetic, in serial computation, LUX simulates normal LU decomposition is showing best performance. In 32 thread parallelization, FX2 double precision complex LU decomposition is also showing best performance. In triple double precision, Ozaki scheme is showing the best performance in serial computation and 32 thread parallelized execution. In quadruple double precision, Ozaki scheme is the best performance in serial computation, but simulated LU decomposition, normal LU decomposition is showing better performance than other algorithms. But in 32 thread parallelized execution, in this part, Strassen AVX2 matrix AVX2 version is showing the best one in this case, but totally simulated normal area decomposition is showing the almost best performance. So this is the summary of complex area decomposition. Simulated normal area decomposition faster for double and quadruple precision arithmetic, and Ozaki scheme faster in serial computation for triple precision, and 32-thread parallelization AVX2 simulated normal area decomposition is faster in general. So we can conclude our talk. 3M method can get 30% better in performance, and double and quadruple precision complex area decomposition is get 721 and 91 times faster than MPLA functions. Simulated complex normal area decomposition shows a good performance totally. And as feature work, we implement sparse matrix multiplication and matrix and vector multiplication, and apply to them to other related algorithms. Thank you for your attention. Thank you.
Thank you very much. So now the time is almost over, but so considering the lost time, if you have a quick question, please unmute and speak. I have just a small question about the simulation. So I saw your slide. You are using intrinsics. So is it easy to extend to AVX 512?
Could you repeat your question? Okay, thank you. Okay, can you hear me?
Yes, yes.
Sorry, could you repeat your question? Sorry.
So you used AVX2. So is it easy to extend to AVX 512?
Yes, that is yes, and I have implemented AVX2 512 version, but we cannot get better performance in real and complex computation. So we do not we cannot recommend to use AVX2 512 version. Sorry.
Okay, thank you. So is there any quick question or comment? If not, how to thank the speaker? But so thank you very much.
Thank you for sorry to trouble. Thank you.
Okay, so Elise-san, can you chair or should I continue?
I can see that Professor Dadonker has joined the room, but I don't know if she can hear us.
I see. So okay, so I will continue to chair. The next talk is from the on-site. I'm not sure who is speaker, but so the talk is by Trang Duan Lee, Verena Cantera, and Laurent de Orazio. The title is Form-Based Semantic Caching on Time Series. This is a talk of general track. So, please. So because time slot is 20 minutes, so please limit your talk in 15 minutes to keep the time for discussion.
Okay. Yes, in just a few moments, we are going to start with the presentation. Thank you.
Okay. Okay, good. Please start.
Could I start? Okay. Good morning, everyone. My name is Chung Dung Lê from Thuy Le University in Vietnam. Today, I will show you my paper about the form-based semantic catching on time series. We are Chung Dung Lê, Verena Cantera, and Laurent Orazio from Vietnam, Canada, and France. And the session I will show you, we have a 5 section with introduction, the background, the form-based semantic catching, and validation, and in the final is conclusion. The first, in the context of the time series data, collect data from many sensor, IoT device, and IT system. We have the solution about the time series data. And another solution is a database manager system. And the another solution for database and manager system is semantic catching. So we always have the question about the complex query in time series data. And the database manager system can use semantic catching with the OLAP query. So another question is the reducing the space of data stored in the in-memory data. So with this context of time series data, we have an existing solution. With the time series management system, we have many database system like InfluxDB, ReadDB, and WebTen. They provide fast ingestion rate and fast selection on time series. But and another solution I prefer that form-based semantic catching technique is used to accelerate the complex OLAP query in time series management system. And the final existing solution is modular DB and modular DB plus. They use a model to store sensor data with lossy and loadless compression in database manager system. And with this, we have a limitation of the existing solution. With the time series management system, they fail to support complicated OLAP query. With another solution, the form-based semantic catching techniques, the sensor data can be stored in the in-memory database, but it still huge. And the final, the modular DB and modular DB plus, they do not apply their technique in semantic catching. So the motivation, we would like to using the form-based semantic catching to accelerate the complex OLAP query in time series management system in a specific time series data system. And we would like to use a model to store sensor data with lossy and loadless compression in an in-memory database. And we would like to reduce the space of data storing in the in-memory database. And with this, we propose a paper with form-based semantic catching on time series, with accelerating the complex OLAP query in time series management system in specific time series data system. With this, it will improving the performance of query processing in time series management system, and they will reduce the time series data store in the semantic catching system. The second section is the background of our methods. We will use the linear regression. With this model, instead of storing all the point, the model-based compression method store the model information. For example, here we have 5 data point, but with the linear regression, we can use only 2 data point to store information of this various time. The another technique we use is semantic catching. When a query is submitted to the system, we can devise our query to probe queries and remainder queries. The first probe query, the result we take from the result available in the local cache, and the remainder query we will take from the server distant server. The listening queue from the server will answer the remainder query. The third section, I will show the architecture of form-based semantic catching. The first, the user can send a query to the system via a web application. After that, the form-based semantic catching will catch and divide it in 2 kind of query. And after that, the time series management system will answer the remain the query, and the sensor will always send the data to the time series management system. With the form-based query, by example, we can use an example of form-based query is that select send dot time with minimize send dot value from sensor as send, where T1 smaller than send dot time smaller than T2. By example, we have the form-based query like this. With the cache management, we use the in-memory database. When the policies we use is the least recent used for eviction of the data. And with the model, we use a linear regression compression. They will reduce the data point of time series data on the key value store. And we can restore all the data point of time series data with the user-defined error bound. Another is in this slide is the form-based semantic catching architecture. In this, you can see that the user can send a form-based query to the form-based query processing. After that, the query will send to the semantic catching model, and the query remainder will send to the distance server, and the distance server will send the answer of the remainder query. Another slide is an example of our methods and architecture. The query can be select time, mean, send dot value, and from sensor send send, where t1 minus smaller than send dot time, smaller than t2. And by example, in semantic catching, we have all the time, all the result from the first to the fifth and the 7 to the 10 of the of date. And the query is from the third to the 10. So we can take semantic the results from semantic catching from the third to the fifth, and the second part is the 7 to the 10. And the query remainder query we can send to time series management system and get the value from get the result from the fifth to the seventh, and after that the result is sent to the user. And the next section is the validation section. The first, we apply the form-based semantic catching in ThinkCity project and the time series data management system is WAP10. In this, we use in ThinkCity, and the sensor can send a message or query to the form-based query processing, and after that, semantic catching model can devise a query to the probe query and remainder query, and after that, the remainder query can be translated into the WAP10 script, and after that, WAP10 script can be sent to the distance server, and the result can be sent from WAP10 to the semantic catching model, and after that the final result can send to the user. In the context of our experiment, we can assume that we have 10 query from the base form-based query is query X in area A from the 1st of February to the 11th of February. Each query we have 10 days. For example, we have like this. And the workload we can test in 6 tests. Like the test 1 have Q1 and Q11. Test 2 is Q1 to Q3 and Q11. In each test, we can see that when we can compare with our methods with the without catching and basic catching. Basic catching in test 1 have already 10% of the result in semantic catching, and 90% is from the distance server. But with the form-based semantic catching, we have 10% from semantic catching, but 45% we can still take from semantic catching, and 45% take from distance server. For example, like this. And with the experiment, we compare in four cases. The first one is the nearly 500,000 bytes of cache. The test 2, test 3, and test 4. For example, like this, and you can see that when compare form-based semantic catching, the execution time is very small when compared to without catching or basic catching. Another experiment I will I will test our methods in the red datasets with the query. The form query is select timestamp value from X from house X, where sensor ID equal to sensor X, and timestamp larger than timestamp 1 and timestamp smaller than timestamp 2. And we have two experiment in red data sets with house 1. The first in the house 1, we can see that with four case like 1,000 timestamp, 10,000 timestamp, 100 timestamp, or 1,000 times, a million timestamp. In this, you can see that the data point with our methods is very small when compared to the original data point. With the next experiment on the data of house 2, we still have the same result with uh, the original of 1,000, 10,000, 100,000, and a million timestamp. With the real data set or a real data point we store in the memory is very small when compared to the original methods. And the final section is a conclusion uh, and further work. With conclusion, our approach accelerate up to 122 and 1.82 times the execute speed compared with the without cache and basic semantic caching approach. And with the red dataset, reference energy disaggregation dataset, the compression model ratio in our approach can be reached to 526 to 1. And with this methods, we introduce a form-based semantic caching for time series database system. Our methods compress and store time series data in the key value stored in the model-based compression, and we implement and validate this contribution in both synthetic and real data. With the future work, we can improve our methods with the more cache management, and we study traditional and specific policies for traditional and semantic caching. It's all of our presentation. Thank you for your listening.
Thank you very much. So now the session is open to the question and comment. If you have any.
Thank you.
So please unmute and talk.
Thank you. And are there any questions?
I have a small question. So the performance should depend on the system. So for example, how the processor is fast and what is the database software. Well, what environment have you tested?
I cannot hear. Could you repeat?
In which kind of a system have you tested? Have you measured this performance?
Can't you
Can,
hear?
can, you cannot hear my voice?
Okay, maybe now we can hear you. Okay, could you repeat the question?
My question is, you measure the performance. So which kind of system have you measured? So what is the database? What is the server?
Mhm. Thank you for your
Muted you.
okay. Thank you for your question. Um, I, I will show you my system. The first one, we apply our methods in the String City project with the time series database management system is WAP10. And the solution for the in-memory database, we use memcache. It's a key value store. And the compression methods, we use linear regression methods. Right? Example, with this, maybe the sensor data cannot train too fast. So the linear regression we use can reduce the number of data set, number of data point in memory database. With this figure, you can see that we have 5 data points. With the linear regression model, we can reduce to only 2 data points. And after that, when we need to restore the data point in the middle, we can use the linear regression to restore with the user-defined error bound.
I see. Thank you. So then the time is almost over. Is there any quick question or comment? Okay, thank you very much.
Okay, thank you very much.
So next talk is again online. So by Rishi Rahmawati and Ahmad Fauti. So if you are a talker, please share the screen. Is there authors of the next talk? Is there Desi or Ahmad?
Well, we can't see Dr. Or Professor Fauzi or Professor Rakmavati. And so maybe we can try to proceed with the next presentation. Maybe they will join the conference room later.
I see. Okay, for the time being, we skip the third talk and go to the fourth talk. So the fourth talk is by Chandri Lucero. So is there Chandri?
She's not here either.
I see. What can we do?
Well, we can wait for them, and in the meantime, maybe we can discuss the previous presentations. If other comments or questions or observations can be made to the speakers, maybe we can continue on with the discussion, if you agree.
Yes. Yes. Okay. So there was two talks previously. So if you have a question or comment you haven't asked, so please unmute and speak.
Yes.
Hideo,
Yes.
I have a question to the form-based semantic casting presentation.
I see. Please go ahead.
Yeah. I think there are kinds of semantic casting. I want to know why you choose a form-based one. Please explain a little about the form-based means. That's my question. This is a question to Turun Don.
Okay, I will. Thank you very much. I will explain our main task. The first one, with the context, the time series data collect data from many sensor and IoT device, IT system. We often use the time series database. It's very good to store, but they have some problem with the complicated or complex OLAP query. In the database manager system, like relative uh, database manager system, we already have the methods to accelerate the query processing by semantic caching. But two kind of system have the limitation that the time series that management system such as InfluxDB, ReadDB, WebTech provide fast ingression rate and fast selection on time range. But they fail to support complicated OLAP query. The original database have semantic caching. They support complex query very good. And we would like to use form based because the time series cannot support all kind of complex OLAP query. So the form based query will provide the many kind of complex query. So, for example, in this, you can see that in time series management system, they cannot support a SQL query. So we apply a form-based query like SQL. So in this is an example of the form-based query. Like a select is a form of SQL query. Example like this, and after that, we translate to the language of the time series management system, like Web10. The, the script in Web10 is very different from the SQL query.
Okay, thank you.
Thank you very much.
And I have another question to Professor Koya.
Okay.
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 You show the three types of multi-component multi-precision scheme, and of
Yes.
them, triple double does not show the better performance for several testing. Uh, do you can you explain why TD is not so in so efficient, not so efficient?
I have I have some I have already accepted a useful comment about this insufficiency of triple double precision and computation. That is, they said that three three components, triple double precision is constructed with three components of double precision, floating point arithmetic, so floating point number. So that is caused by that is caused the uh, inefficiency of triple double precision arithmetic, triple double linear computation by when compiler optimize our library. So I understand. So.
Oh, okay. Thank you.
So now it is the official time to start the fourth slot. But so is there Chandri Rosello? Or one of the third speakers?
They are still not here.
I see. Maybe we
So
should wait for another 5 minutes to expect the So the Chandri Rosello is in trouble to connect.
okay. In that case, when the chair fill the forms that I have shared with them, they also could sign the two missing presentation as no show in the paper's evaluation form. If I may ask you this favor, this courtesy.
I
Thank you
see.
very much. So I think we can wait for them, and if they still don't join the conference room, we can close the session whenever you consider it fit. Okay?
Yes, but just a moment.
Yes, yes, of course.
So still if you have some questions or comment, please discuss. Either the first or second speakers. I have a question to the technical assistant. So I cannot see the session chair form. Maybe because I'm not a formal chair.
I sent you a link a few minutes ago.
By mail?
Not by mail, but
Chat?
by a private message on this same platform.
Yes. Yes, I see. But this is just the, yeah, so the,
It was me. I am Alfonso Annunziata. I am the technical assistant of this session. And yes, I sent you by private message the link to
yes, I
the.
received. But this
Okay.
link is just so the usual ESS ICCSA.org. So I can log in, but so I can see just the usual menus for the participants and the chair. No special
Yeah.
menu for the chair.
No,
The
not a
session
special
chair.
menu, but you see, you should see among the options also a link to the evaluation form.
No, just I can see the
Okay.
just familiar ones. See the abstract, see the papers and reviews, assignment, and see all the camera ready pages.
Okay. I try and send you again the link. Did you receive it?
Yes. Yes, but so this is maybe the same.
The same thing? It doesn't work?
It seems the same as before, so I cannot find. So what is
Or
page for the chair?
maybe because you are not enabled, since the expected chair was Professor De Donker. Maybe she could
Maybe.
access she can access the form, but I see that she has left the session. So maybe we can either try and contact her and share this link with her, or otherwise I can fill the form.
Yes.
Okay, thank you very much. I
So
also guess that we can close the session.
so it's okay. 10 minutes past. So maybe so should I? We should close the session.
I guess.
Thank you very much.
Thank you very
Bye
much
Thank you.
bye. Bye
all the
bye.
participants.
Thank you for your cooperation. Thank you.
Thank you for joining this session.
Goodbye. Thank you very
Goodbye.
much.
Goodbye.